Alright, so in this video we will talk about public good provision. The idea here is that there are n players. There's a public good that could be provided. So think of something like a road or irrigation for a bunch of farms that has to be built together, something of that sort. Where the cost of the public good is C. Each player, we restrict how much each player can contribute to be either 0 or C. The public good is provided if at least one person contributes, and the value of the public good can be different for different people. So that value is Vi, and it lies between V lower bound and V upper bound, and it follows a continuous distribution Fv, where Fv is the probability that Vi is less than the value V. And the continuous distribution simply means that there aren't any sharp jumps or flat areas here. Everything has positive probability, every range has positive probability, but no point has positive probability. Okay, let's define this game a little more formally by writing out the players, beliefs, states, actions, and all that. The players here are the n individuals. The states. So each profile of valuations, so if there are 5 people, then the combination of each of their valuations is a particular state. So the set of states is the set of all profiles. V1 through to Vn, where for each Vi we have the condition that V lower bar is less than Vi is less than equal to V upper bar. The actions, so for each player, the action will be either 0 or C. Right, because for each player, all they're going to choose is either to contribute or not to contribute. The signals. The signal here, so depending upon what the state of the world is, which is V1 up to Vn, that profile, that signal just generates your own actual valuation and nothing else. You don't know anything about anybody else's valuations. The beliefs depend entirely on the distribution function f of v, and player I assigns probability of f of v1 times f v2 times f up to vi minus 1 times f vi plus 1 times f vn to the probability that vj what I'm going to do is add hats here, just to be clear that these are particular values. So this is the probability that V1 is less than equal to V1 hat, and V2 is less than equal to V2 hat, up to Vn is less than equal to Vn hat. And what this probability means is that for each of them, this is the likelihood that player 1 has a valuation less than V1 had. This is the likelihood that player 2 has a valuation less than V2 had. These valuations are all drawn independently, so you can just multiply them to get the joint distribution. And the payoff function finally is going to be 0 if no one contributes. Because then the public good is not provided, but also you haven't contributed anything towards it, so you get 0. Vi if someone other than I contributes. So if player I doesn't contribute but somebody else does, then player I gets the benefits from this public good but doesn't have to pay any cost towards it. And Vi minus C if player I contributes. Right, because then player I gets the valuation Vi, but player I has also contributed towards the public good provision, and therefore player I incurs a cost C, which gives player I a payoff Vi minus C. So now we try exercise 290.1. Let's see if you can see it here. Okay. The idea behind this is to find the conditions under which player I always contributes when player I has a valuation Vi greater than or equal to C, but nobody else ever contributes, and player I doesn't contribute when player I has a valuation that is less than or equal to C. So I'm going to erase this. Okay, so when will this hold? So we know that nobody will ever contribute if their valuation is less than C. So if Vj is less than C, no contribution. If player I can be convinced that nobody else will ever contribute towards the public good if that public good is, like, nobody else will ever contribute towards that public good irrespective of their valuation. If player I can be convinced of that, then player I would want to contribute if her valuation is at least C, because at least that way she gets 0 or something greater. Right? So we want to show that no one else will ever contribute. Right, and we want this to be an equilibrium. So with no one else contributing, we want to find out conditions where player I will contribute, and there no one else is contributing because player I has a likelihood of contributing. So as player J, as a player other than player I, if I contribute, I get Vj minus C. If I don't contribute, I get 1 minus f of C times Vj. And I want this right-hand side to be greater. What this is capturing, this 1 minus f of C, this is capturing the probability that Vi is greater than or equal to C, right? Which is basically the probability that, sure, you're not contributing, but player I is. Right? This is the probability that player I has a valuation that is at least C. So for this to hold, if we just simplify this a little bit, we get Vj minus C is less than equal to Vj minus Fc times Vj, which further, I mean, we can just get rid of these two Vj's here, and that simplifies to f of C is less than equal to C divided by Vj. Right, as long as this holds, yeah, as long as this holds, then, did I skip a step here? I don't think I did. So as long as this holds, then all players of type J with a valuation Vj would choose to not contribute. But we want this to hold for all players regardless of their type. And so we make the strictest assumption, which is Vj can take all values between V lower bar and V upper bar. This inequality is most restricted when we plug in Vj equal to V upper bar. And so what we need is that f of C should be less than equal to C divided by V upper bar. Right, and that is a restriction on this distribution. This is 1, this is V upper bar, this is V lower bar down here, and let's say this is C. The restriction is that f of C should be small enough that I am not willing to contribute. So what it does is it puts more mass, more likelihood on the valuation of player I to be in this region. And if the valuation of player I is between C and V upper bar, then player I is more likely to contribute. And so what this restriction means is that, okay, as long as player I is likely enough to contribute, all other players can just chill. They don't need to do anything to get the public good. Player I will alone be willing to contribute towards it. Okay, so this is public good provision.